Okay, so now what we have a foundation in the graphing of all of those polar, we're going to find the area and like arc lengths and everything with those graphs. So it's going to be lots of fun. Okay. So here, if I remember back into trig pre-calculus, we have the area of a sector is just this 1/2 theta r squared. So we can find if we know like the theta that we're at, theta, and then like how far out we are, then we know that we can just take that to find the whole area of what that sector would be. So we're basically going to kind of be doing this by thinking through of these sectors as kind of like Riemann sums, and we're going to be adding and adding and adding all of those together until we basically have infinite pieces where instead of like this having any width at all, we're going to have that width go to 0. So that we just have all of those lines basically being added up. And it gets us to an integral for our area in polar. Okay? So I don't know why a lot of times the 1/2 gets lost, and then make sure that you square your r when you're doing these. All right. So let's go look at the first one. Here it's giving me the graph, it's giving me the equation, and it wants me to find the area from negative pi over 6 to pi over 4. So it is looking for this area going on. So I am taking the integral of 1/2, and it's already got the r squared. So there's r squared. It told me I always go the smaller to the bigger one. Okay, we've got to go in order of the movement. So this one we could definitely do without a calculator. It could be on a non-calculator section. The 1/2, the 2 cancel here, and I just have cosine. So the antiderivative of cosine is sine, and we're going to evaluate from negative pi over 6 to pi over 4. Sine of the negative pi over 6 would be radical 2 over 2 minus sine of pi over 4, I don't know why I just said that. Sine of pi over 4 is radical 2 over 2 minus the sine of negative pi over 6, which is negative 1/2. So that is radical 2 over 2 plus 1/2. Just thought it backwards in my brain for a second. And, matching, it could try to put it all into one fraction. Who knows? All right, so this is going to be more of what you'll have to do is not have the function in front of you, and you have to kind of get it from what they're asking. So it just wants one petal, and here a petal is a key word. We know that there's 2, so we're going to draw 4 petals, and they have a length of 6 to go out. So let's go find our tangents at the pole. And then those become repetitive. So I know that I have tangents at the pole at here 0 and pi over 2. So now I'm going to make my r theta chart. But, I mean, honestly, I could go ahead and know that it's going to be symmetrical with 4 petals. So they're going to have to be at these values. Okay? So, like, pi over 4 is going to be the 6. 1, 2, 3, 4, 5, and the 6 for that length. Over here, I'm going to have it end here. Okay? So I kind of already know that from 0 to pi over 4, I go this way. and then I hit back at pi over 2 for that 0 again. So 0 to pi over 4 to pi over 2. And we can draw the rest of all those petals and see, okay, that with this symmetry, and we could have used all of this, but with this symmetry, if I find the area of one petal, then I can multiply by 4. And heck almighty, I could even find the area of half a petal and multiply by 8. So in this case, we really didn't even need to think that much about the r theta from our understanding. So I'm going to go ahead and just say I'm going to find the area of one petal, since it said, oh, it just wanted one petal. And I'm just going to go ahead and go the full way around. So I'm going to go from 0 to 2 pi and find the area of this petal. Or pi over 2, not 2 pi. 0 to pi over 2. So I know I want to do 1/2 the r squared. And this is a calculator active one, so you can go ahead and put that into your calculator. You could try to do it by hand, it's kind of fun. So if you did it by hand, you'd get 9 pi over 4, and make sure that you can put that into your calculator to get 14.137. Okay. Okay, again, one petal. I know I'm going to have, in this case, 3 petals with a length of 2. So let's go find them. So cosine equals 0, pi over 2, 3 pi over 2, 5 pi over 2, 6 pi over 2, 5 pi over 6. And let's see what happens so far if we need to go out more or not. 6, 2, 6, and I've got all of them that I need. Okay, so now as I make these, I know that if I get some point in here, then since it's odd, the petals would be in those places. And if I got someplace here, then it would be in those places. And even, it would be in all of them. But since we have an odd, we kind of just need to figure out if it's in any of those, like where it's located. Okay? So we're going to make an r theta chart. And really, if I can see where I'm at 0 and see which one it's going to fall into, like either go backwards or forwards, that's going to be as far as I need to go. So cosine of 0, 1 times 2 is 2. So here I can see that I am at 2 at the 0, and then I'm going to hit right there at pi over 6. And if I know that, then I could sketch the rest of this curve. I know that that petal's going to go, and then this one, and then skip, and then this one. Okay? But for this, I'm going to just find this half petal and multiply by 2 to get the full petal. That way I don't have to worry about like finding, like going further and trying to find more information. It's just I've got half a petal, multiply it by 2. So I have 1/2, and I know I'm going to multiply by 2 from 0 to pi over 6 of my r squared. If you want to try it by hand, you would get 4 pi minus 6 radical 3. Otherwise, this would actually be on the calculator section, and that's what you would get. Okay. Next example says find the area of an inner loop. So inner loop, guys, do something like that. That's an inner loop. So it wants me to find the area of just that inner loop. All right, so let's go draw this graph. Where does this guy equal 0? Sorry about that. All right, so 2 pi over 3 and 4 pi over 3. Our theta chart. Get my 0, pi over 2, and then I want to include the 2 pi over 3, and then I can see the pi, and then get the 4 pi over 3, and then go back. Okay, if I need to, let's see what's going on. Pi over 2, plug it in. We already know these are zeros. And then at pi, negative 2. Let's go get this graph. 1, 2, 3, 4, 5, 6. Let's set theta equals 0. Then when I face this guy, I'm at 1, 2. And then I'm at 0. So I'm kind of moving in this, remember, counterclockwise shape. And then at pi, I am back 2. And then at 4 pi over 3, I am here again. And then let's keep going. Let's get to 3 pi over 2. I think you can go ahead and graph it, though. I think you can see it in that 2 pi. And then 6. So 1, 2, that goes here. And then we come all the way around. So we are traveling this way. And it wants me to find the area, oops, of this inner loop. Okay, so we could go and start where it starts right here at the 2 pi over 3 and end at pi and get half and then multiply by 2. Or we could go to pi to 4 pi over 3 and do the same thing. Or we could go from 2 pi over 3 all the way to 4 pi over 3. So I'm going to do what I just graphed, and I'm going to double half of the petal. And I'm going now from 2 pi over 3 to pi. These guys cancel. And you can try it by hand. Oh, you guys, I think I wrote that one for the other guy. I'm so sorry. I did. Oh, I'm crazy. I'm glad I just caught that. This one is pi over 3, or 1.043. Okay. This one is either 4 pi minus 6 radical 3 if you did it by hand, or in the calculator, which is fine, is 2.174. Okay, last one for this section of graphing, and then we'll move on to a level up. Well, this one's still kind of a level up. But wants you to find the area between the loops. So we still know we have a loop-de-loop guy. Let's go find our zeros. So there's different ways that we could see where sine of theta is negative 1/2. I just like to say negative pi over 6, right here. but that's the same as saying 11 pi over 6. It's kind of up to you. And then again at 7 pi over 6. Okay. All right. Now we're going to make our theta chart and get some points on there. I'm actually going to, since I started backwards, I'm going to start at negative pi over 6. And then go to 0, pi over 2, pi, 7 pi over 6, 3 pi over 2, and then back to 2 pi. Okay, so I knew that that was 0. Let's go plug in. I know that this one's 0. I can go ahead and get those. So plug in 0. 2. Plug in pi over 2. 3 times 2 is 6. Pi, that's 0. I get out 2. 3 pi over 2. Now negative 1, negative 2, negative 2. Okay, let's see how that gets me so far. So at negative pi over 6, I'm at 0. And then when I face 0, I am at 2. So I'm actually going this way. And then when I face this, I'm at 6. 1, 2, 3, 4, 5, 6. And then at pi, I'm at 2. That was probably too skinny. Okay. And then at 7, there's my pi, there's my 3 pi, oops, pi over 2. And then when I face this guy, it said that I am at negative 2. And I'm coming back around again. Okay, because that's where I started. It's kind of where I end, is there at the origin or at the pole. Okay, so this one asks me to find the area between the loops. It's a little bit harder. Okay, so for this, I think of a lot of times when I say like, oh, find the area of the shaded region. So what would you do? You'd find the area of the square and then subtract out the circle, the area of the circle, and then you'd have the area of that shaded region. Well, it's the same concept here. You're going to find the area of the big and then subtract out the area of that little guy, and then you'll have what you are looking for. Okay? Okay, so I'm going to call it just big and small. Let's go find the area of the big. So the area of the big, and you guys, so many times, and I'm going to start it here. Different color here. I'm going to start here and end here, and then multiply that by 2. So this one actually started at negative pi over 6, remember? And then it went up to pi over 2. And I'm going to double that of my r squared. Then I'm going to subtract out my small little guy. So for my small little guy, I am going to, let's see, I have some options. But as I work my way through, I can start here and go to here and then double by 2. So remember, this one was the 7 pi over 6, and this one was 3 pi over 2 as I start and stop. So I'm going to take that and double my formula of the 1/2 from that 7 pi over 6 to the 3 pi over 2. And there could have been, like, you could have done the full circle Okay, if you wanted from 7 pi over 6 back to 11 pi over 6, or you could have done 3 pi over 2 to 11 pi over 6, but I like to just do the first part of that r squared. And then I just put that all in one big thing in my calculator and got 33.351, or if you just decided to truncate, 350. If you really challenged yourself and did it by hand, that's what you would get. Okay, so that is going to be the end of that day. We're going to do one more day after this, and then we are finished with the unit. Woo!